All right, we are moving into our last section of Chapter 2 that we're going to do, and this is on distance and midpoint formulas as well as circles. And I've found that a lot of students are very comfortable with these because a lot of times you're just working with formulas. But there is a part in here that we have to remind ourselves about completing the square when we were solving quadratic formulas. That's going to help us out with our circles. So let's get started improving the distance formula. Circles are everywhere in life, from clocks to maps to compasses and even butterflies. The rectangular coordinate system gives us a unique way of knowing a circle, and it enables us to translate a circle's geometric definition into an algebraic equation. So basically from a geometry shape into an equation that we can work with. In order to do this, then we need to develop a formula for distance and also for midpoint, which will be coming up shortly. So I'm going to start by looking at, on a rectangular coordinate system, if I call this point 1 and this point 2, I'm going to say that this is x1 comma y1, and this is the point x2 comma y2. And what I want to develop is the distance between those 2 points, okay? How far is it from here to here? Now, in a one-dimensional sense, that's not too bad. But when we start moving things diagonally to find this distance, d, we are going to be looking at doing a more complex formula. Okay, now, if this is my origin, this is the x-axis, this is the y-axis, and I need to locate this point that's right here. I have claimed that that is x1, y1. So that means if I go out on my x-axis, this is going to be the distance x1. Coming up here, this is the distance of y1. And locating this point, I go out to x2 to locate that point. So this is going to be x2. And up here, across there, that is the distance y2. And whatever they are, that's what we recognize them as. Now, here is what's going to happen. I'm going to drop what we call a perpendicular from this point and over to there, okay? Now, what I've just created, if it's perpendicular, remember there's a nice right angle there. And there is a theorem that you should remember whenever we are talking about a right triangle called the Pythagorean Theorem. We worked with it a little bit before, but that is the case where if I know the legs of a right triangle, we can do the a squared plus b squared equals c squared, okay? And find that c squared. Now, I need to determine what is this distance and what is this distance. Well, let's just, for the purposes, if I said that this is 2 and this is 8, what's the distance from 2 to 8? Well, from 2 to 8, that's 6 things that we would have to walk, so the distance would be 6. How do we get 6 from 8 and 2? We would subtract 8 minus 2. Therefore, this distance that I have from there, if I subtract x2 minus x1, that's going to give me that number for the distance. Anytime we find distance, go way back to find the distance formula. We took a minus b in absolute value, or b minus a in absolute value. Likewise, if I want to know what this distance is, it's going to stem from what is this here and finding the difference between those two. Therefore, then I'm going to represent that by y2 minus y1 because y2 is bigger. That would give me a positive value. Okay, so I now have 3 sides of a right triangle, and I can use Pythagorean Theorem in order to determine what that relationship is. So I'm going to say, okay, this hypotenuse squared, we're going to say d squared, is equal to this a squared plus b squared. So I'm going to actually do the x's first. I'm going to say that's x2, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So this is my a squared plus b squared equals c squared. A squared plus b squared equals c squared. Okay? All right. Now, I do not want d squared. What I want to do is to find the distance, okay, d. So when I square root both sides, don't forget when we did that, we did like a little plus or minus over here on this side. So technically, D is equal to plus or minus the square root of all of this x2 minus x1 quantity squared plus y2 minus y1 quantity squared. But if you recall, distance is a positive number. So what I'm going to do is to write, choose the positive version here, okay? And that's what we're going to get right down here in our distance formula. The distance D between 2 points, column x1, y1, and x2, y2, is given by this long square root formula. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And that's going to give us the distance between any 2 points on our coordinate plane. So you got to be careful, make sure that you have the pluses and the minuses in the right spot, and that you don't get it confused. It's minus in between the or the parentheses and plus in between. So find the distance between the following points. Express the answer in simplest radical form and as a decimal. Okay, so we are going to look at doing the distance. And I'm just going to call this x1, y1, call this x2, y2, which we did a lot when we worked with slope. We're going to take x2 minus x1, so we're going to do 2 minus a negative 1 squared. Be careful with those negatives. Then I'm going to go 3 minus a negative 3 squared, but I have to plus in between there. 3 minus a negative 3 squared. And again, all I'm doing is plugging into this formula. And then we have to simplify. So by order of operations, we have to go inside these parentheses and simplify first. Now, 2 minus a negative 1. Hopefully you will go automatically and make that a plus. Same way here. These double negatives become a plus. So what does that become? Well, this becomes a 2 plus 1, which is a 3 that I need to square. Then I'm going to add to that a 3 plus 3, which is a 6 that I'm going to square. And then I'm going to go from there. Now that the parentheses are gone, we need to go to exponents. So the exponents is 3 squared, which is 9. 6 squared is 36. And when I add that together now, it gives me the square root of 45. Now that is not in simplest radical form because there is a perfect square that is a factor of 45. So I want to break it as my perfect square times what's left over. So 1, 4, 9, 16, 25, 36, all of those, which will go into 45. It is a 9 times 5. Therefore, when I square root 9, I get a 3 square roots of 5. And that is going to be the simplified radical version to that. Then I'm going to figure out the decimal version of that by going to our calculators. Now, with the 2-line calculators, you can just plug that in and you get a decimal version to that. I forgot to do it on my notes, so I'm doing it on my phone as I speak. And I had to enter in 5 square root and then times it by 3. And what you should get is 6.71 if I rounded it to 2 places. So there's the decimal version, and that is the simple radical version. When we talk about distance, sometimes, a lot of times, that numeric part right there is going to be the most helpful. Okay? All right, let's go to the next spot. All right. Now, then another important formula that go hand in hand together most of the time is this midpoint formula. So, used with geometric shapes is the midpoint formula. The midpoint is defined to be the point which is equidistant from the endpoints of a segment. So if I have this segment AB from geometry, you should know that this guy here is approximately the midpoint of that segment. So, given the endpoints of a given segment, we're going to call it x1, y1 again, and x2, y sub 2. The coordinate of the segment's midpoint is defined to be x1 plus x2 all over 2, and y1 plus y2 all over 2. Now, hopefully that makes sense. We're going to add together the x's and divide by 2, add together the y's and divide by 2. So if I'm adding 2 things and dividing by the number of things that I have, basically to find the midpoint, we want to average the x's and average the y's. So if I were to take the average of your two test scores, I would add them together and divide by 2. That's exactly what we're going to do here with that midpoint, okay? So notice that in this formula, there are no minuses whatsoever. It's always add. So that's where a lot of my students get mixed up with whether I subtracted or added. So make sure that with midpoint that you add those to find the average, okay? So that'll get your middle point. So for our midpoint, we're going to take x1 plus x2. So that gives me a 1 plus 7 divided by 2. Then I'm going to take y1 and y2. So I'm going to take 2 plus a negative 3. And then divide by 2. Simplify from here. Again, it's a formula. Plug in the numbers and simplify. So I get 1 plus 7 all over 2, which becomes an 8 over 2. And here I get 2 plus a negative 3, which is a negative 1 all over 2. Now I can still keep going because one of those I can simplify a little bit more. So 8 divided by 2 is a 4. This can't be simplified. So the best I can write it is negative 1/2. If you were to graph those out on a coordinate plane, you would find that that gives you the midpoint. Okay? All right, very good. So we now are moving into the idea of our algebraic equation for a circle. Okay? So we have a definition of a circle, and hopefully I can maybe shine some light on how that we found the equation of that. Definition is that a circle is a set of all points in a plane that are equidistant from a fixed point called the center. And the fixed distance from the circle's center to any point on the circle is called the radius. So the two important things that we want to make sure that we have is going to be the center and the radius. Now, the idea of that circle, okay, I'm going to give you an idea here, okay, where I have a fixed point. We're going to call that HK because that's going to represent our center, and we have this being R as our radius. I can, for any point XY on my circle, I could use my distance formula to prove that I have the equation of a circle. So if I wanted to do the distance formula, I'd take x minus h squared plus y minus k squared is equal to r squared. Okay? All underneath that, the distance formula, r is equal to the square root of, x minus h squared plus y minus k squared. And then, so let me write that so you see it. So if I don't want the square root in the general formula for a circle, we don't want that big long square root. So if I square both sides, what I end up getting is the equation of my circle. Okay, so the standard form for the equation of a circle with center HK and a radius R is this. So I square this, the square root goes away, and I'm left with x minus h squared plus y minus k squared equals, which means I square the left side over here, becomes an r squared over here. And that right there is what you want to remember when working with a circle. Okay? All right, if you know that formula, life is a lot easier than if you don't know that formula. So we want to write the standard form of the equation of a circle with a given center and radius. So here is my center. There's HK. There's my radius. What we're going to do, throw all three numbers into here, into bam, 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 right there, okay? So I have x minus 0 squared plus y minus the k value, which is 4 squared, equals r squared, and I'm just going to throw in that 3 squared. Okay, now, probably you can leave it like that, but we probably want to simplify it a little bit more. So if I do this, x minus 0 is just x. So I could actually just bring this down to just x squared plus, we don't want to square that out in general form. It's kept in the parentheses, so keep it in the parentheses. And we can do the 3 squared, which is 9. Therefore, this would be the equation of our circle with that center and that radius. Now, let's look at this next version. We have an HK here. We have a radius to the square root of 5. So if I then put each one of these into my formula, so we're going to have x minus a negative 2. Now notice this, double negative becomes a plus. Then we're going to add to that our y minus our k value. So minus a negative 1 becomes a plus 1 squared. This is the version that I always do, is equal to the radius squared. So we have the square root of 5 squared. So let's rewrite this left side as simplified as we can as that x plus 2 quantity squared plus a y plus 1 quantity squared is equal to, now the square root of 5 squared. Square root of 5 times square root of 5 is just 5. Square root of 3 times square root of 3 is 3. Square root of 7 times square root of 7 is 7. Or you could do square root of 5 times square root of 5 is 25, but square root of 25 is 5. So remember, that just comes down to 5 when you square a square root. Okay? All right, very good. So that, again, hopefully is not too bad. Let's kind of go backwards in a sense, where I give you an equation. Can you actually tell me the center, the radius, and also graph it? After you graph it, it's much easier to then find the domain and the range, okay? So the biggest thing to remember is, in the general formula up here, what you are looking at has an original minus there. So it kind of goes back to the idea when we were working with transformations. If it's grouped inside with parentheses, you have to take the opposite of what you're looking at to extract out the actual number. So if this is a minus 1 that you see, do the opposite, and that becomes a positive 1 for the x value of my center. Do the opposite of what you're looking at, and that gives me a negative 2 for the y value of my center. So you have to do the opposite, or just remember that the original has a minus in it, okay? Now, this is r squared. So what we have to do is actually square root that right side to figure out what our radius is. Is r squared equals 9. If I square root both sides, my radius equals 3. Now, technically, there's a plus or minus there, but remember that distance is never negative. All right, so let's do that point, and then we will figure out our domain and range after we graph it. So I'm going to graph the point 1, negative 2, which is right here. The easiest way to graph a circle, I say, is to graph your center and then go north, east, south, and west, the distance of your radius. That's the easiest way to find those threes. So I have 1, 2, 3 up, 1, 2, 3 over, 1, 2, 3 down, and 1, 2, 3 to the left. And right here is my guide to construct my circle. A lot of times mine look like eggs. Yeah, that one's not too bad. But now this visual is very, very nice to be able to tell me what the domain of that circle is and what the range of that circle is. So for my domain, the allowable x's start at negative 2 and go as far out as 4. So we're including those. So we have to do our brackets here as negative 2 to 4. And our range, it is as low as negative 5 and as high as positive 1. So we want to go from negative 5 to 1 as our range. Okay? All right, very good. Let's do the next one. The next one is in standard form. If I take the opposite of what I'm looking at, that is the x value of my center, notice this guy doesn't have anything. So it's very similar to this one up here where if there's nothing there, that is actually a 0, invisible. Here is my r squared. So when I take the square root of that number, what did I square to get a 4? It is a radius of 2 here. Again, figure that out, the center and the radius, graph it. Then we'll find our domain and range. So let's go out to negative 3, 0. There's my center. Let's go north, east, south, and west by 2 to figure out where that circle's going to lie. I'm going to graph that circle. Sketch it around there. And now I'm going to use that visual to determine my domain and my range. So we go from negative 5 to negative 1 on our domain. And then we're going to go from negative 2 to positive 2 on our range. And that, ladies and gentlemen, is our domain and range for that circle. Okay? All right. Now we get to kind of probably the most difficult part of circles, where we have to incorporate our completing the square, which it is not too bad. Again, let's make sure we just follow the steps that I give you, and it should just kind of work itself out. So our final task is to take a circle in general form, which is this, x squared plus y squared plus, let's go, dx plus ey plus f equal 0. That's what your book constitutes as general form. We're going to take that into standard form. And remember what standard form was. X minus h squared plus y minus k squared equals r squared. And so notice that we're forcing it to be a quantity squared. So in order to do this, we will have to complete the square in order to identify our center and our radius in our standard form. So this is how that we're going to do it. Here's some 5 simple steps that we can use in order to get there. So we're going to group the x's together, the y's together with the constant, which is just the number, don't forget, on the other side. Now, we're going to prep for completing the square at the same time by putting your sets of parentheses with the x's, y's, and both with the constant. And I'll illustrate that in just a second. Now, we're going to take half of the linear terms of the x's and the y's and put those in the parentheses. We're going to break the x's and y's down to our quantity squares, simplify the constant side, then we get to identify our center and radius. So here, we're going to kind of group 1 and 2 together in a sense, because we're going to kind of prep at the same time that we separate things out. So maybe kind of put those together. So it says that we have to group our x's together and our y's together with the constant on the other side. So that means first up, I'm going to have to bring this 4 over here. So that would be equal to 4. But I'm going to group this x with that x and this y with this y. Okay, and it's going to look like this. We have x squared plus a 2x. Now, I'm going to prep for my completing the square, because this is the version right here that I have to now force it to be one of those quantities squared. So in order to prep, I'm going to start by writing our parentheses squared that we're going to get ready to do, okay? Then we're going to group our y's together as y squared minus 4y. I'm going to prep to complete the square. So remember, we take half of the linear term and add the square of that to both sides. And then set that equal to, when I bring that 4 over, by adding that 4, that means if I'm going to add this in over here, add this in over here to keep it balanced, I have to add them in on this side as well. Okay? So, I know that's long, but it is what you have to do. Okay. So, I'm looking, can take half of the linear term and the x's and put these in those parentheses. So, probably completing, so I'm putting in parentheses, set of parentheses squared. I'm going to come back up here and modify that right there as a quantity square, because you have to have the square of that to both sides. Okay? All right, now, here we need to take half of our linear term. The linear term are the middle terms of each one of those. The power of 1, that's the linear term. So if I take half of 2, that is a 1. Take half of 4, that is a 2. That means I also have to put that on this side as well. Okay? So be very careful making sure that you do both the x's and the y's. So now, step 4 is that I have to kind of break down each one of these. And if I've done it correctly with taking half of the linear terms, putting it in their parentheses, then we're forcing that quantity squared. We're forcing this quantity squared here, and we have to simplify this over here. So 2 squared is 4, 1 squared is 1, 4 plus 1 is 5, plus 4 is 9. That should be the easy part. Okay, now on the left-hand side, remember when completing the square, we take one of these, we take one of those, and the front sign matches. We take one of these, we take one of those, and the front sign matches. So what I now have is a standard form for my circle that I have started with in a general form, taking it down to a standard form, okay? Then now I can, from the previous page, identify my center and my radius. So take the opposite of what I'm looking at, the opposite of what I'm looking at. The center becomes -1, 2. And if this is r squared, remember, we have to square root that to determine that my radius is 3. So -1, 2, there's my center. To find my circle and graph it, we're going to go north, east, south, and west by 3 in order to graph our circle. Okay? And that's how you do that. Okay, so I know those steps right there were very, very quick, but make sure you follow them. Rewatch this again. Group your x's together, prep for a quantity squared. Group your y's together, prep for a quantity squared. Bring your constant to this side and add those quantity squareds again. Force that to be a quantity squared, then extract your center and radius. All right, so let's try this guy. Again, we're going to do the same thing. Write it in standard form and then give the center and the radius. Okay, so I'm going to bring this over. Now notice in this equation there's not a linear term for x. There's not just a 4x or something like that. So that means I only have to do the quantity squared once on the y's. Okay, that means that here that x value of my center is going to be at 0. There's not a quantity squared that's going to happen. So I'm going to only have to prep once. Y squared minus 6y. I'm going to do a quantity squared. Now this one here I'm going to subtract over, be a -8. And so we are going to do our quantity squared on this side as well. This has to match over there. Over here we had 2 of them, so that's why I had to have 2 here. And so this time I'm only going to complete the square on my y. So by taking half of the linear term, which is a 3, that has to go on both sides. And now I'm forcing, rewrite my x squared, I'm going to force this quantity squared equals -8 plus 9 is, whoops, not 9, it's 1. Alright, so now what goes inside here with my y squared minus 6y plus 9 in disguise? I need one of those, I need one of those, and the front sign matches. Therefore, that is my standard form equation. So, what is the center? I need to take the opposite of what's with the x. Well, that, remember, is a 0. Take the opposite of what's with the y. That is a +3. Therefore, 0, 3 is my center. This is r squared. Take the square root of that. Gives me a radius of 1. And I'm going to graph that. 0, 3 is right here. North, east, south, and west. 1 on each one of those. And that gives me that small little circle right there. And that is it. That's what we have for that. Now, I do want to make note to you that if you do this quantity squared out and all of this down, and you end up with a negative number here, if I try to square root that negative number to find out what my radius is, I would end up with an imaginary number. So if that number at the end is negative, then there is no circle. Okay, they've given you kind of a bogus equation. So you always have to kind of make sure that you keep that in note and also kind of think outside of the box with that. So if that n number is a negative, there could not be any circle whatsoever in that. Okay, so hopefully you can practice that and master the idea of circles. I think that completing the square part is kind of fun, but that's just me, to where I can break something down so nasty and then bring it down into something that I can create a center, a radius, and then graph it from. Okay, so make sure you master this, and we will move on to chapter 3 after this. Until next time.